All right. So the chain rule is going to help us find more complex derivatives. What's important about the chain rule is that it is used for composite functions. Okay? When we have a composite function, we have to use the chain rule. Okay? Composite function. I'm throwing out vocabulary that you've heard before, but some of us need to maybe remember what it is. Take 30 seconds and see if you and your class can come up with what a composite function is. 1, 2, 3, go. I'll give you time to write down. Just right now, I want you to tell me what a composite function is. Talk about it. Okay, pause 3, do you remember? Michael said, isn't that like f of g of x? Oh. Okay, for example, the tangent of x squared, that is a composite function. Okay? When we have a function inside of a function, we must use the chain rule. So we're still going to be using our power rule, product rule, quotient rule, and trigonometric rules along with the chain rule. Okay, so Michael gave us what a composition looks like in general, right? So let's look at what the derivative looks like in general, okay? I wouldn't worry about writing this paragraph down. This just says f is differentiable and g is differentiable, then the composite is differentiable, okay? Which is this. The derivative of the composition is f prime of g. So like we take the derivative of the outside and leave the inside alone. So everyone stop writing right now. Let me explain this and then you can write it down, okay? We're taking the derivative of the composition, okay? We take the derivative of the outside function, leaving g inside, and then we multiply it by the derivative of that inside function. Okay, write it down. Do I need to raise that up for you back row people? Do I need to make it higher? Like, do I need to move the page back? That's what you make it back. Are you ready then? Okay? Now, I'm going to show you why this is the way that it is. Okay? This is in your book as well. Okay? Don't worry about writing it down. But, okay, so if y is f of u and u is g of x, right? Basically, this is the composition, right? I just broken it apart into two different functions. Okay? What happens is we take the derivative of this with respect to what's inside, so dy du, because that's what's inside. Okay? Here, we take the derivative of u with respect to x. And then what happens when we multiply these together? The du's cancel, and we are left with dy dx. That's why the chain rule works the way that it does. Okay? Don't need to worry about giving me this. Just need to worry about that right there. Okay? So, the only way to get better at this is to practice, practice, practice. First example. All right, so the derivative of f. What's our outside function? Cosine. What is inside cosine? X squared plus 9. So we take the derivative of the outside, which is negative sign, leaving the inside alone. And then we multiply by the derivative of the inside, which is so our derivative is negative 2x sine of x squared plus 9. Next one. Is this a composition? Yes. If the answer is yes, that means we can use the chain rule. The only way we can do this derivative right here. Okay? What is inside our function? 2x. 2x is inside the sine of x. We have a composition of two functions. So our derivative, what is the derivative of the outside? Cosine. Leave the inside the way that it is. Times, the derivative of the inside is 2 cosine 2. Questions so far? So far, so good? Okay. Next one. Is this a composition function? In order to be able to use the chain rule, you need to recognize if we have a composition or not. Is this a composition? We have 5 minus 3x inside of our square root. Do you agree? Can we break that square root apart? If there's addition or subtraction, you cannot break apart the radical, okay? We can only break apart a radical with multiplication and division, okay? So this is a composition because we have a linear function inside of a square root function, okay? What should we do with our square root function before we take the derivative? Very good. We should change this to 5 minus 3x to the 1/2 power. That way, when we apply the chain rule, we can use the power rule as a part of it. Okay. All right. Derivative. First of all, the outside function. What is our outside function? We have something raised to the 1/2. That is our outside function. So we're going to take the power rule to take the derivative of the outside. So 1/2, leave the inside alone, the power drops by 1. Then what do we need to do? Multiply by -3, right? So I would rewrite this to -3 over 2 5 minus 3x to the 1/2. Right? 1/2, the negative power means it can be moved to the denominator, so it can be positive power. Okay? The 2, that's a fraction, so it gets the denominator. Okay? You had a question on your quiz the other day that looks like this. When you found the derivative, what was your strategy last week? Okay, you actually multiplied out 2x plus 4 times 2x plus 4, and then you used the power rule 3 times, right? Okay. Could we now go a different route? Okay. All right. What about this though? What if I change that to like a 10? Right? That would not be fun. Okay. So let's just talk about what this would look like as a chain rule. Is this a composition function? It is. We have 2x plus 4 being squared. So if we want to take the derivative, what is our outside function? Okay, 2x plus 4 is what is being squared. So 2x plus 4 we would consider our inside function. Our squared is what's on the outside. Okay? So to take the derivative of something squared, we use the power rule. Right? Decrease the power by 1. And then multiply it by 2. So we get to the same place. We get to 8x plus 16. Okay? Now, in this case where we have 2x plus 4, the quantity squared, it might be a wash which way is faster. But if I gave you like 2x plus 4 to the 4th power, okay, you don't want to sit there and multiply it out to do the power rule. Okay? If I gave you 2x plus 4 to the 4th power, okay, I would be fine with you taking the derivative using the chain rule and leaving your answer as 8 times 2x plus 4 cubed. Okay? I would not expect you to multiply that all out. Okay? But that's a pretty nice little chain law, right? You don't have to multiply that out 3 different times to get our derivative, which is just chain law. All right, let's try another trig one. Yeah. Okay, is it the top or the bottom one? The top. The top one? Is that better?
Yeah.
Okay.
Thank you.
You're welcome. Trig ones I feel are more obvious to see which one is our inside versus outside function. Okay? If we have a trig problem and the angle is not x, okay, our trig function is our outside function. Okay? How about you guys take the derivative and see what you get? Yeah, I'm gonna have you guys do this one. Check with your pad when you come to an answer. You just copy that one, right? Where's that X? All right, good. I'm saying secant squared of x squared plus 1 times 2x. Okay. One thing that I saw from like 6 or 7 people, okay, is that you wrote, oh, the rule is secant squared x, and then you put your angle in there. Make sure your angle just stays as is, okay? I understand, like, we're learning the trig rules, so you need to look back, you look at it, you wrote it down, forgot about that x. Just be careful. Make sure that inside stays the same. Okay? New one. Okay, this one is a trig. Hold on. Let's decide though, is this a composition? You think so?
No, I mean, no.
It's just,
It's just there.
okay, Q says it's a composition. What function is inside another function? This is true. It is tangent of x times tangent of x.
Am I on the right track?
Well, you're turning it into a product rule, which is fine. However, I want to keep this as a composition, and I want to know what function is inside of another. Ideas from the crowd. What function is inside of another function?
It's the,
X is inside of tangent. We can take that derivative without the chain rule.
yes. I don't think it's a function.
Would it help if I rewrote this as
Yes.
tangent is being squared, right? So tangent right now is our inside function, where the power rule is like our outside function, like the x squared, something squared is our outside function. So we have to take the power rule first, multiply the power, subtract the power by 1, and then we can multiply by the derivative of the inside, secant squared x. I want to talk about how we could do this one without using the quotient rule. Okay? It's nice to have options in math. Do you agree? Okay? Some of us are going to see this and use the quotient rule. That's awesome. Is there a different way we could approach this?
I think I know.
Cool?
Can you put it 2x minus 2 all raised negative?
Is that mathematically equivalent? Do you agree with Cole? Okay, I think it's a good idea. Now we can use the chain rule, where on the outside we have a function raised to the negative first power. So we could write -1 times leave the inside alone. Our power decreases by 1. And then we would need to multiply by the derivative of the inside, which is 2. So our derivative is -2 over 2x minus 2 squared. Another option instead of having to use the quotient rule.
Are we allowed to like multiply the negative 2 out for the parentheses and then put that over negative 2? So like negative 4x 4 all over negative 2.
What?
Well, you know, like the middle right there. You can do negative 2 times 2x and then 2 times negative 2.
Okay, since this has a power of -2 and this does not, you can't multiply them together. If it has a power of 1, you can multiply things through. Anything else? No. Let's do this. Okay. What is our inside function? Oh, that quotient right there. That quotient is our inside. Outside function is something raised to the 7th power. So our derivative of the outside function. We multiply the power out in front drop the power by 1. That's the nice part, right? Now we have to times by the derivative of the inside, which is a quotient. It's not a bad quotient, though. It's linear on the numerator and denominator. Okay? Here we go. We have low d high minus high d low all over low squared. Okay. Can anybody tell me what our numerator simplifies to? Huh?
The numerator.
Uh-huh. What did you say?
I said 13.
Just 13? Because this is 6x plus 10 minus 6x plus 3.
Agreed.
Does anybody want me to go through that? Okay. Now, I am fine with your answer the way that it is. Let me tell you what the back of the book is going to do so you don't panic. The back of the book is going to take 7 times 13. What's 7 times 13?
Oh, okay. 91.
Is it?
91.
91. You can take 91 times 2x minus 1 to the 6th. Basically, they're going to break apart this numerator to the 6th, this denominator to the 6th. So we have 3x to the plus 5 to the 6th and 3x plus 5 to the 2nd. So they're going to write it as 3x plus 5 to the 8th. That's how they're going to write their answer. Like I said, I am perfectly happy if you get to here, okay? But this is what the back of the book is going to do, and if you like that, go ahead and go all the way to there. But I'm not going to be too worried about that. Okay, trying to decide here. This will be the last one we do, probably. All together, at least. I might give you one to do on your own. Okay, this one's pretty obvious to tell what's inside, right? We have 1 plus x to the 5th cotangent of x inside of our something raised to the negative 8 power, right? What's the first thing that we need to do?
First,
I like that little gesture there. Take that negative 8 down. Oh, very good. And our power becomes negative 9. Now we need to multiply by the derivative of the inside. Do you notice how I'm using parentheses? Parentheses are always a good idea when you're multiplying. That way you don't get tripped up with any like negative signs that you think, oh, was this multiplied by a negative or is it subtraction? Okay, always do parentheses. Okay, so derivative of the inside. What's the derivative of 1?
0.
0. How do we take a derivative of x to the 5th times cotangent of x?
Lose a 5 over. The product rule.
Okay,
Oh.
did you hear me say x to the fifth times cotangent of x? It is a product. We have to use the product rule. Okay, so let's practice that again. Product. Derivative of the first times the second plus the first times what is the derivative of the second? So let's make this look a little nicer here. What we have is negative 8 times all of that, 5x to the fourth cotangent of x. I'm going to write this as minus x to the fifth cosecant squared. Okay, I'm going to go ahead and take that negative and multiply it through. And then since we have a negative power, we know that that can be moved down to the numerator. That would be a nicer way to put your answer. Okay. If you want to multiply that negative 8 through, you can. Not going to make it a big deal.
If we kept like the top one of the text, did you take on that one?
Well, I would at least want you to rewrite it so this was like subtract x to the fifth cosecant squared x, and I would be fine. Okay. I just don't like leaving something like this. All right. I want you to do one more example for me. Without me. Ready? It is not easy. I would consider the cosine to be multiplied. Okay, let's talk about this because some people are trying to use the product rule. I can see where you would think that this is a product. But if you have the product between something and a constant, what's a derivative of a constant? 0. Don't do the product rule. Okay, do you remember that constant rule? If you have a constant times a function, when you take the derivative, you can take the derivative and multiply the constant to it, okay? The constant just travels along with it. It stays along for the ride. Don't do the product, okay? So instead, what I would want you to do, I think I saw at least most people recognizing that that is cosine being cubed. And so what I would want you to do for this one would power rule, so 6 cosine squared x, and then we would multiply it by negative sine x because that's the derivative of our inside function. Okay? I'm glad we talked about that one then. If we have a constant on the outside, it's going to stay along for the ride for the derivative. Okay? Don't ever worry about the product rule if it is a constant. If that was 2x, we would need to worry about the product rule. But if it's just a 2, a 5, 10, 1,000, constants just stay along for the ride. Okay? All right, so you will find your homework on your gold sheet. Okay? I don't know if you noticed, but there are a lot of different types of problems that we can use the chain rule for. So it's going to be important that you do your homework.